Drying reduces the amount of water contained in the crop after harvest to an acceptable level for marketing, storage, or processing. Lowering the moisture content is necessary to prevent grain spoilage, which is primarily caused by molds and insect infestation. Both grain temperature and moisture content are critical in maintaining quality. Agricultural commodities that are improperly dried could impact overall quality of the produce. Sensory attributes of food such as color, texture, flavor, and aroma are affected. Uneven moisture of stock could contain high MC above safe moisture for storage. High moisture content of the stock allows molds to grow, which also produces mycotoxin. Improperly dried seeds also lowers germination and vigor. Safe moisture levels for safe storage depend on grain variety, length of storage structure, and climate. There are numerous factors which must be taken into account for successful drying. Here are some food attributes that affect drying process. Shape of commodity affects drying by the amount of material contained in a surface area. For spherical materials, its rate of drying is its radius or half its diameter. This is because water must move from the center of the sphere along its radius to reach the surface where it will be removed. Food commodity like slabs or flat plates offer a large surface area to volume ratio, which increases the rate of drying when compared to spheres. The characteristic dimension that controls drying of flat slab is one-half their thickness if both their top and bottom surfaces are exposed to the flow of air in the dryer. Size and thickness of food material also affects drying. Water removal in a drying process depends on how far the water has to travel from the center of the material to its surface. For this reason, large pieces of food tend to dry more slowly than smaller pieces of the same food. An open structure tends to be more porous than a tighter or more dense closed structure. Moisture is able to find its way through the pores and travel to the surface in products with a more open structure. The composition of the material itself has a significant impact on this. The actual amount of water present in a given material will influence how fast it may be dried to a desired final moisture level. Commodities with high initial moisture dries much slower than food products with low initial MC. Some food commodities have outer coating that prevents moisture from escaping. For this reason, the skin traps the moisture which surrounds the seeds and prevents them from drying out. Hence, grains without an outer covering dries faster. Grain quality largely depends on the grain type and its end use. It includes a range of properties that can be defined in terms of physical, sanitary, and intrinsic quality characteristics. Food quality and components are affected by drying process. Components found in food are those which are sensitive to heat. These include vitamins. When subjected to excessively high temperatures, the beneficial properties of these components are either completely destroyed or substantially reduced. For this reason, it is best to impose limits on the drying temperatures of most food products. If too much moisture is removed or the temperature of drying is too high, products may become brittle and literally crumble into small pieces rather than retaining their original desired structure. Flavor and aroma are often due to the presence of essential oils. If attention is not paid to the drying conditions of products containing delicate oils, the oils themselves may be driven off by the heat or oxidized by chemical reactions with oxygen in the heated air. Color changes such as browning or toasting can occur by several reaction pathways during the drying process, if conditions of temperature and time are excessive. Moisture is removed quite rapidly from the surface of the material. It may be removed so fast that the hot air starts to make a hard dry layer on outer layer due to the collapsing of cells at the surface. This hard layer severely reduces the efficiency of the drying process and may prevent the trapped moisture from escaping. High grain kernel temperatures during drying have the most detrimental effect on quality. The negative impact of high temperature on desirable quality characteristics can be limited by using air temperature sufficiently low and avoid exceeding the maximum. Low temperature drying, which uses unheated air, is also referred as Easter drying or near ambient drying. In low temperature drying, the objective is to control the relative humidity or RH so that all grain layers in the deep bed reach equilibrium moisture content or EMC. For medium and high temperature drying, heated air is employed in which the temperature of the drying air is controlled. Medium temperature drying with heated air that keeps grain kernel temperatures below 43 degrees Celsius for seed grains and below 60 degrees Celsius for grains to be milled and processed. High temperature drying with heated air keeps kernel temperatures below 82 degrees Celsius for animal feeds. High temperatures for rapid drying is applied and the drying process is terminated when the average moisture content reaches the desired final empty. Combination drying uses both low and higher temperature air to reduce the grain moisture content to a safe storage level. Effects of high temperature drying are as follows. High temperature drying can lead to excessive thermal and moisture stresses in the kernels and thus to stress cracking. It increases amount of stress cracking or fissuring and breakage susceptibility of corn and rice. It also increases amount of surface wrinkling and kernel shrinkage in small grains and cereals. Years of research and experience have clearly shown that the development of stress cracks can be minimized by avoiding overdrying and controlling amount of moisture removed for drying rate passed to less than 5% points per hour for corn and sorghum, 3 points per hour for soybeans, and 2 points per hour for rice. High temperature drying reduces the yield of grits and flour during milling. It reduces the baking quality of wheat and diminishes the yield and quality of oil from oilseed. High temperature drying reduces protein content in feed grains and reduces the germination value in seed grains. Strict end user demands and a more competitive export market will continue to increase the importance of grain quality throughout the entire grain production and processing chain. The handling of grain according to specific intrinsic characteristics such as oil, protein, and starch content is becoming the norm. Grains are classified into coarse grains such as corn and sorghum, cereal grains which include wheat, durum, oats, barley, and rice, small grains like canola, flax, and mustard, pulses such as lentils, peas and edible beans, and oilseeds including soybeans and sunflower. These various grains require different drying conditions or temperature. The table shows the maximum kernel temperature limits which is recommended during drying. For corn seeds, the limit is 38 to 43 degrees Celsius. For dry milling, 38 to 43 degrees Celsius. For wet milling, 54 to 60 degrees Celsius. For corn intended for feeds, 71 to 82 degrees Celsius. For popcorn, which is used for snack food, the limit is 38 degrees Celsius. For wheat seed, the limit is 43 degrees Celsius. For flour, 49 to 66 degrees Celsius. And wheat used for feeds is 74 to 85 degrees Celsius. For durum, the limit is 57 to 63 degrees Celsius. Drying temperature limits for barley for malting is 41 to 49 degrees Celsius. Barley for feed, 74 to 85 degrees Celsius. Oats for flour or feeds, 63 to 79 degrees Celsius. Rice for milling, 40 to 44 degrees Celsius. Soybeans for seed, 38 degrees Celsius. Soybeans for oil crushing, 49 degrees Celsius. Canola for oil crushing, 41 to 49 degrees Celsius. Flax for oil crushing, 38 to 49 degrees Celsius. Sunflower for food, 60 to 77 degrees Celsius. Sunflower for oil crushing, 77 to 91 degrees Celsius. Peas, 52 to 66 degrees Celsius. And beans, 38 degrees Celsius. Any hygroscopic material, including grain, has its own characteristic balance or equilibrium between the moisture it contains and the water vapor in the air with which it is in contact. This is known as the equilibrium moisture content or EMC. The EMC, which corresponds to 70% equilibrium of relative humidity or below, is the condition that establishes good grain storage conditions. The following are the equilibrium moisture content or EMC values of the grains at 27 degrees Celsius and 70% relative humidity. Maize, 13.5%, wheat, 13.5%, sorghum, 13.5%, millet, 16.0%, rice paddy, 14%, cowpeas, 15%, and ground nuts or peanuts, shelled, 7%. Here are some important notes for drying of grains. Chemical and physical changes are slowest in a product with low moisture content. Most fungi do not develop under 70% relative humidity. Grains must be checked for safe MC before storage. High temperature can lead to excessive thermal and moisture stresses in the kernels and breakage. High grain kernel temperatures during drying have the most detrimental effect on the quality. For GrainPro drying solutions, please visit www.grainpro.com. Thank you.